Hey everyone, and welcome to The Explainer. Today we're diving into something that's, well, one of the biggest questions in AI right now, all thanks to some really fascinating new research.
I mean, just think about this for a second. An AI could tell you the right answer, but for a completely wrong reason. How would you even know? Imagine an AI says a patient needs a specific treatment. The answer could be right, but if the logic it used to get there is all messed up, then trusting it is a huge gamble, right? So the real question is, how do we peek inside the AI's brain and actually check its work?
Well, that's where this new paper comes in. Researchers have just built a brand new way to do exactly that. This is all about getting to an AI we can not just use, but one we can genuinely, truly trust.
Okay, so first things first, we need to talk about a specific kind of AI that's at the heart of all this. And let me tell you, it's not your everyday chatbot.
So you've heard of large language models, or LLMs, right? They're kind of like a student who just gives you the final answer. A large reasoning model, or LRM, is totally different. It's like that student who shows you all their work, every single step, their whole chain of thought. And what this research is all about is finding a way to make sure that chain of thought is 100% correct.
So how do they do it? How do you build a system that can actually check an AI's homework? Well, what they did was pretty clever. They took an existing tool and basically gave it a massive upgrade, turning it into a superpowered safety net for AI.
And the secret ingredient here, the thing that makes it all work, is this idea of uncertainty. Think about it. For us to trust an AI, it kind of needs to have a little humility, right? It needs to be able to know what it doesn't know. To say, hey, I'm not totally sure, but here are the most likely options. Okay, so that old safety net I mentioned, it's a technique called conformal prediction, or CP. The way it works is, you ask an AI a question, and instead of giving you just one answer, it gives you a small set of possible answers. And here's the cool part. It comes with a statistical guarantee, like a 95% promise that the actual right answer is hiding somewhere in that set. It's a really great tool for managing risk.
But, and this is a huge but, there was a critical flaw. That old safety net, it only cared about the final answer. It had no idea how the AI came up with its options. So you could get a set of answers, and sure, the right one might be in there. But every single one could be based on completely bonkers logic. And that is a massive problem.
And that is where the big breakthrough comes in. The researchers created something called CoRAP. This is the upgraded safety net. Get this, it doesn't just check the final answer. It checks the reasoning that leads to the answer, making sure it's logically valid. So the guarantee you get isn't just for a correct answer, it's for a correctly reasoned answer. That's a game changer.
And they didn't stop there. They went a step further. To figure out why an AI reasons well, they pulled in this cool concept from game theory called Shapley values. Just think of it as an MVP finder for the AI's training data. It sifts through everything the AI learned from and points out the exact examples, even the exact steps in those examples, that were the most valuable players in teaching it how to think correctly.
So, okay, that's the theory, right? You've got this new safety net, CoRAP, that checks the reasoning, and this MVP finder that tells you where the good reasoning came from. Sounds great on paper, but does it actually work? Let's see how they put it to the test. So to really push their system, they use some pretty complex data sets, like this one, called CLEVR-Math. The AI would get an image just like this, and then a question that forced it to both see and calculate. So in this case, it has to first find the one big, brown, shiny sphere, and then it has to reason through what happens when you add 4 more. The correct answer, of course, is 5.
And here you can see the difference it makes. On the one hand, without CoRAP, the AI's reasoning is just a mess. It's confusing objects, the logic is all over the place, and it gets rejected. But with CoRAP, look at that. The AI has to lay out a clear, logical, step-by-step path to the answer. It's a path that we can actually follow, verify, and ultimately trust.
And the numbers absolutely back this up. What you're looking at here is the failure rate. See that dotted line? That's the maximum acceptable error level. Notice the blue bars? That's the old method. They're jumping above the line pretty often, which means it's failing more than it's supposed to. Now look at CoRAP in orange. It stays safely and consistently below that line. It is just flat out more reliable.
And it's not just about being reliable, it's also way more efficient. Remember how the AI gives us a set of possible answers? Well, you want that set to be as small as possible, right? Take a look at the bar on the left. The old method gives this huge set of like 5 or more possible answers. Not super helpful. But CoRAP, over on the right, narrows it right down to just 2 or 3, so it's not just more reliable, it's way more precise.
Okay, but any good piece of science is honest about its limits. And being upfront about what a study can't do yet is absolutely crucial for building real, lasting trust.
And the authors here are super clear about this. They point out that their work was mostly tested on visual and math problems. They say, look, we still need to do more research to see how this holds up in situations that are just pure text, like analyzing a legal contract or a doctor's notes, where the whole idea of reasoning is just a different beast. That's really the next frontier for this research.
So keeping those limitations in mind, let's just zoom out for a second. Why does all of this matter so much? I mean, what does a future with a truly trustworthy AI even look like?
Because this isn't just some theory stuck in a lab. This is literally about building the foundation we need to use AI safely out in the real world, in our actual lives.
I mean, just imagine an AI in medicine that doesn't just give a diagnosis, but also shows its work. A perfect, logical chain of reasoning based on your symptoms and your history that a doctor can look at and instantly trust.
Or what about in law? An AI that chews through thousands of cases and not only finds the right one, but proves it didn't misread a law or miss a crucial detail along the way.
And in science, think of an AI that comes up with a new hypothesis and then lays out every logical step and every piece of evidence that led it there. It could speed up discoveries in ways we can't even fathom right now.
So yeah, this research definitely gets us a big step closer to that future. But it also leaves us with a really tough question. We know human experts have biases, we know they get tired, they make mistakes. So if an AI can prove, time and time again, that its reasoning is sound, at what point do we start trusting it more than a human? That's a big one. I'd love to know what you think.